Hi everyone, welcome back to the next instalment here about numerical integration. So this is where we finished off last time. Now I'm going to consider what would happen if instead of doing these rectangles with the height of them at the left hand edge, what if I drew these rectangles and I took the height of them to be the right hand edge of each of these little strips. Now this time, because my function is increasing here, this time I'm going to end up with a little bit of an overestimate. It's going to be, these rectangles are going to be a little bit larger than the area underneath the blue curve. Everything else I had done earlier, most of it would still be working. I'd still call this x0, x1, x2, xn. I'd still have my lower limit of 2 and my upper limit of 5. Now, I'd still calculate a width of 1, but this time I'm not going to start with x0. I'm going to start the first rectangle, the height of that rectangle is going to be the value of x1 substituted into the function. Then the second rectangle, I'll use x2. The third rectangle, I'll use x3, or more generally xn if I had a different number of strips. So pretty much the setting out is the same. I'd still have the width w times each of these heights, so I could factor the w to the front of the equation. Now the numbers will differ slightly, so I'll be well, obviously the result will differ as well. Let's go back to my calculator there, if I can find it. There it is. So remember we did a little list in the table here. Now this time x1 is the value 3. So when x equals 3, the height of the function is 8.7. That's my first rectangle, is 8.7 now. Then 12.8, then 17.5 for the last one. So I'll write those. Oops, having trouble over there on the other screen. So I'll write those in. So 8.7 helps if I have the pen selected, doesn't it? Then 12.8, and finally 17.5. So when we add those up, what are we going to get? Well, let's see. 7 and 8 are 1.5 plus another is 2. Carry the 2. There you go. 2 and 8 are 10, plus 2 is 12, plus 7 is 19. Carry the 1. 1 and 1 is 3. So I have 39.0 square units. Somewhat larger than the answer I got last time. Not unexpected at all, because each of these rectangles is a little bit taller than the blue line. So the area underneath that curve, it's a bit less than 39. And from the left-hand rectangles we did earlier, we found a bit of an underestimate. If you like, we have a lower and an upper boundary. The true area is somewhere between those two answers. Of course, I could get a closer approximation if I used a greater number of strips. If n was not 3, if I divided that into 10 segments or 20 segments, I'd get two numbers for the upper and lower boundary, the left and the right rectangle sums, which were much, much closer together. So you can see this technique of numerical integration. It's terribly easy. It's just a bit tedious and time consuming if you want to get an accurate answer. But it's still a very valuable method to know. All right, that's enough for this one. That's the right-hand rectangle sums. Thanks for watching.